Okay guys, what we're going to have a look at today then are some water of crystallization calculations. So as we looked at earlier in one of the moles topics, water of crystallization is water which is trapped within crystals of an ionic solid, essentially as that ionic solid forms from an aqueous solution. So there's two types of calculation that you need to be able to do here. The first one is to calculate the percentage of water of crystallization in a compound. So just work out what percentage there is of water in the compound. The second calculation you have to be able to do is then actually to calculate the number of moles of water of crystallization in a compound. That's a slightly more difficult calculation. Okay, so the percentage of water of crystallization is very easy. We take our example here of what we call pentahydrated copper sulfate. Penta meaning 5, hydrated meaning water, and copper sulfate, obviously the CuSO4. So water of crystallization is recognizable, guys, by the fact that you have dot something H2O. So this value here is a variable, okay, and very often represented by X in an exam question, or by N, where the examiner will ask you to calculate X or N from given data. So how do we calculate the percentage of water in this particular compound? Well, we do it very simply by taking the moles of the water in it, which is in this instance is 5 multiplied by the RFM of water. So in other words, you have 5 times 18 on the top line, which is 90. Okay, and on the bottom line it's the RFM of the compound. Now this is the RFM of the entire compound, okay, including the waters. And remember, the 5 H2O means you have 10 hydrogens and 5 oxygens. Okay, so you have 5 times 18, 16 plus 2, 5 times the entire thing, not just, people drop marks because they just multiply the hydrogens by 5 and forget about the oxygens. So the entire RFM of that whole thing there is 250. Okay, so it's 90 divided by 250 multiplied by 100 gives you 36%. So in other words, of this molecule, 1 mole of hydrated copper sulfate, pentahydrated copper sulfate, is 36% water. Okay, so we'll do a few of those and hopefully you'll be able to get them right. And again, just like the other videos, if you think you've got it, just pause the video, have a go at it, and then come back and check your answer with mine. So I'll just do 3 or 4 of these because they're fairly straightforward, I think, and then I'll do a few of these. Okay, so if we take an example of, let's say, magnesium sulfate, 3H2O. Okay, so again we work out the mass of the water in it. So the moles of the water is 3 multiplied by 18 is the mass of, okay, so that's 54, and the mass of the entire thing then is the mass of magnesium. Let's put the calculator there. So we have magnesium, which is 24, plus our sulfur, plus our 4 oxygens, plus, don't forget to put the water in. Okay, so that gives us 31%. So magnesium sulfate, hydrated magnesium sulfate, is indeed 31% water. Okay, let's take barium chloride. Okay, and this time we will take it, it's just a half of a water in there, so please be aware of that. Okay, it shouldn't really cause us any particular difficulties in working it out. So if we just refer to water is half moles of water multiplied by 18, okay, which is obviously 9, and then our barium chloride here is 137 for the barium chloride, and our two chlorines are 71, plus remember to add your half water, which is 9 to that. Okay, gives you 217. Okay, so it's 9 divided by 217 times 100, okay, gives you 4.15% water. Okay, let's take a last one because these I think are really very easy indeed. Okay, so we have 2 moles of water, so 2 times 18 on the top line. We have on the bottom line we have calcium, which is 40, plus 32 for our sulfur, plus we have 4 oxygens, which is 64, plus or 36 for our 2 waters, which is 172. So we have 36 divided by that gives us 20.9% water in hydrated calcium sulfate, which is gypsum, by the way. It's referred to as gypsum in various GCSE questions. Okay, so let's have a look then how we can work out the amount of water of crystallization in a compound through experiment. Well, the way you do this is you take a little crucible and you put some of your solid into it. So let's say it's CuSO4.XH2O. So we're going to be asked to work out this. And what you do with that is you pop it into a little pipe clay triangle, and then you simply heat this really very strongly. Okay, and as you heat it, what will happen is that the water will evaporate off. Okay, and the reaction that will happen then is CuSO4 plus XH2O. So in other words, you have removed all the water. So if we know what mass of this we started off with, and we know what the mass is at the end, well, then we can work out. So if we call this A, and we call this B, we can work out A minus B equals, we call the mass of water C, and that is simply the mass of water. Now this is where your empirical formula from earlier comes in, because this is essentially what this is. It's a ratio of copper sulfate to water. So whereas our empirical formulas earlier in this topic were one atom to another, this is essentially one compound to another. It's exactly the same. So if we can work out moles of this and we can work out moles of that, then we will be able to work out the molar ratio of that to that. That's essentially what we're doing. We're applying the empirical formula technique that we learned earlier to this. Okay, so therefore if I can work out moles of B, okay, so that would be B divided by the RFM of B, and that will give me moles of B. Okay, and I can work out C, which is the mass of water, divided by 18, or the RFM of C will give me moles of C. So we'll call N for moles, N for moles, and then all I want to do is work out the ratio of that. Okay, and the ratio of that, it will always work out that this, okay, ratio will work out that we can make this as 1, and this will be X, and that will tell me what this value is. So that's essentially the theory behind it. That's what we have to do, and that's what we will do in the calculations that we are going to carry out now. So make sure you have a calculator, make sure you have a periodic table, okay, and make sure that you remember from the last time that number of moles equals mass over RFM. Okay. Okay, so we're going to have a look at a problem here where we've been given, the examiner's given us hydrated aluminium nitrate with this formula. We've got to work out what X is. So the information in the question is that the mass of the evaporating basin is 54.13 grams. The mass of the evaporating basin plus the hydrated salt, i.e. all of that, is 61.63. And the mass of the evaporating basin after heating to a constant mass is 58.39 grams. So we've got to work out from these values here what the masses that we need, really. So it's not a matter of just being told what the mass of the water is, or the anhydrous salt. You've got to do a bit of processing and interpretation of the question here, guys. The reason why it's heated to a constant mass is to ensure that all of that water has gone. So what you would do in the experiment in class is you would heat it for a while, then you would weigh it, then you'd bring it back and heat it again, then you would re-weigh it. You'd probably do that about 3 or 4 times until you get 2 or 3 constant masses. Okay, just to make sure that all of that water has actually been removed. Okay, so how are we going to work out the information that we need from these values? Well, the mass of the hydrated salt must be the 61.63, this value minus this value. That's the empty basin, that's the basin with all of this salt in it. So the hydrated salt is that. So then, after we heated it, the mass dropped from that 61.63 to 58.39. So that must be caused by loss of water. So the water is 61.63 minus 58.39, so we have 3.24 grams of water. Okay, so our original hydrated salt was 7.5 grams. We lost that much water, so therefore the 7.5 minus the 3.24 must tell me what mass of anhydrous salt, or salt, there is without the water. Okay, so that is 4.26 grams. Right, so we want to work out, remember, moles, so the ratio we want to work out moles of that to moles of this. Okay, so we must then convert our moles of anhydrous salt into, our mass of anhydrous salt into moles of anhydrous salt. So that is the mass of anhydrous salt, that's the RFM of the anhydrous salt. Remember that number of moles equals mass over RFM. Okay, and that is 0.02 moles of that. That's a nice round number, so I'm pretty confident I'm along the right tracks here. If I got a really awkward long number with several decimal places in it, I'll be a bit concerned there. Maybe go back and check your work. Here we've 3.24 grams of the water divided by the RFM of water, which is 18, gives me 0.18. So the ratio of moles of here to 0.02, notice the 0.2 to 0.18 is 1 to 9, therefore it's 1 mole of the anhydrous to 9 moles of the water, so X must be therefore 9. Okay, so that's a typical example of one of these types of questions that you would get, guys. Alright, so we'll have a go with another couple, and again, the thing to do is that if you think you understand it, I'll write the question out, then you simply pause the video and have a go at the question itself. Okay, right. Okay, so let's have a look at a few of these. So I'm just trying to find a few. I've got some right. Okay, so this is a compound called borax. Okay, and borax has a formula of Na2B4O7.XH2O. Okay, so the examiner here has told us that we started off with 7.28 grams of hydrated borax, so of Na2B4O7.XH2O, and he's told us that we've ended up with 4.04 grams of the anhydrous borax. So anhydrous obviously means without water. Okay, so we need to do our calculations. and work out, well, the first thing we're going to work out is how much water was actually lost, and that's pretty straightforward. 7.28 minus 4.04. Okay, so we had 3.24 grams of water there, and we'll just quickly divide that by moles of water. So we'll just work here. Water, we had 3.24 over 18 equals 0.18. Okay, so that was our moles of water. We need to compare that to moles of our anhydrous salt. So our moles of our anhydrous salt was 4.04, which is the mass of the anhydrous salt divided by the RFM of this. Okay, and the RFM of that is sodium is 23, so we've got 2 of them, which is 46. Boron is 11, we've got 4 of them, which is 44, and we have 7 oxygens. Okay, so that gives us over Na2B4O7, we end up with 0.02 moles. Well, this is pretty familiar, isn't it? Exactly the same ratio as the last one, so it is 0.18 over 0.02, so x equals 9 again. Okay, so that was nice. Same answer for both questions. That was a simpler question certainly than the previous one. So we'll go on ahead and have a look at another one. So if we flick back here, so these do come up pretty regularly, guys, and they can be relatively tricky, but okay, so this time we have got a hydrated copper carbonate. So copper carbonate is CO3.x H2O. We've been told that our empty crucible, I'll just write CRUC for crucible, 24.21 grams. We have our crucible plus CuCO3.x H2O is sitting at 27.31 grams, and we have our crucible after heating is 26.43 grams. So again, we've got to work out from there the amount of water, the mass of water, and we've got to get the mass of the anhydrous copper carbonate. So those are the two values we've got to get. Right, so my crucible was 24.21, this was 27.31, so my mass of my hydrated salt must have been 27.31 minus 24.21. Okay, so my hydrated salt, in other words this stuff here, was 3.1 grams. It dropped from there to there after I heated it, so what that means is that 27.31 minus 26.43 was the water. So in other words, that was 0.88 grams of water, and I started off with 3.1 of that. So if I do 3.1 minus answer, that means my anhydrous salt must be 2.22 grams. Okay, so we'll convert that into moles of that by dividing it by the RFM of water, which is 18. So I have 0.0488, and my copper carbonate, so copper is 64 plus 12 plus 3 oxygens is 48, so that's 124. Okay, my moles of this then is 0.0488 0.18. Okay, so if I do 0.0488, divide that by the answer, that gives me 2.7. That does not look quite right. Let's just go back and double check our figures here. Okay, so we had 27.31 minus 26.43. Okay, divided by 18.0488. Okay, and we had 26.43 minus 24.21 equals 2.22. Well, they look fine. So we have therefore got 64 plus 12 plus 48. Okay. Right, 2.22 divided by the answer is 0.0174. That looks fine. And we had that. Right, so 0.88 divided by 18 divided by the answer is 2.7. So x there must have a decimal on it, guys, which is rather bizarre, but that is the answer, 2.7 according to my calculations. Okay, right, so moving on then to the previous page, which is page 16. Okay, this time we are looking at some sodium carbonate. So we've Na2CO3.XH2O. Okay, so we started off with some crystals. So we have a hydrated crystal, in this case at 2.675 grams. Okay, and the after it was heated, okay, so after it was heated, it came down to 1.325 grams. Now, there's no mention of crucibles or anything in here. Okay, so it's just dealing with the solid itself. So the mass of water, okay, so the water must be that minus that, because that would account for the loss of mass. So it's that number of grams. So the moles of water is that over 18. Okay, which gives me a 0.075 moles of water. Alright, the anhydrous, this loss of water means that that's how much anhydrous salt I had, that being the anhydrous salt. So of the Na2CO3, I must have had 1.325 divided by the RFM of that, so 1.325 divided by 2 sodiums are 46 plus 12 plus 48, which is 0.0125. Okay, so this number is smaller than this number, so we divide 0.075 divided into the answer. Okay, so the water to Na2CO3 is 6:1, so therefore our value for X is equal to 6 there. Okay. Okay guys, well, I mean, that's as many as I'm going to do. I would suggest to you that you maybe surf the net for a few of these. There's plenty of them out there. The ones that I've just done are all GCSE past paper questions. There will be some in your textbooks, there'll be some in GCSE textbooks in the library. So hopefully you understand this by now. Okay, so we're going to do another few of these water of crystallization calculations just to finish off, guys. So we have a sheet here with a few on. I'm going to work through them. These are ones that are available to you if you want the hard copy. I can email them to you if you ask me. Otherwise I'll work through a few of them here, and then any more you want you can ask me for. So the first one we have here, we have been told that we have some hydrated copper sulfate. Okay, we've been told we have 6.25 grams of that hydrated copper sulfate. We've told that it was heated until the mass remained constant, and that mass was 4.00 grams. Okay, so if the mass remained constant, that means that it is the anhydrous solid. In other words, there is no water attached to it anymore. So we've got to calculate out X. Okay, well this should be fairly straightforward. We have copper sulfate, which is our 64 plus our 32 plus our 16 times 4. Okay, so that gives us our mass of 160. Okay, and we have our water, which is H2O, which is 2 times 1 plus our oxygen, which is 16. So that's 18. So that's our anhydrous copper sulfate. That's our water. We just need to work out what's what. Well, if there was 4 grams left, that means there's 4 over 160 is the number of moles of the anhydrous copper sulfate, which is in this instance 0.025. The water must have been the amount of driven off here, which is 6.25 minus 4. Okay, so that's 2.25 moles of that, and the moles are grams of that, not moles, and that's divided by 18, so that gives me 0.125. so this is obviously the larger number. So we divide the smaller number into the larger number, and in this instance 0.125 over 0.25, sorry, 0.025 means that X is equal to 5 in that case. Alright, pretty straightforward one. Right, let's have a look at the next one. Next one brings an equation into play, and that equation is the reaction of nitric acid with calcium carbonate to give you calcium nitrate plus carbon dioxide and water, obviously. Okay, now so let's have a look at what's going on here. Okay, so the examiner tells us that the student left this solution of calcium nitrate to crystallize, and the crystals that were formed contained 30.5% water by mass. So in other words, the hydrated crystal that forms, okay, when you leave this aqueous solution, of all of that entire thing, 30.5% of it was water. And from that we've got to calculate the formula. We've got to work out how much of it, or what the value of X excuse me, is, well, if 30.5% of it is water, well, the remaining must be calcium nitrate. So in other words, 100 minus 30.5 is equal to the mass of that, which is calcium nitrate. So that means 69.5 grams is indeed calcium nitrate. Now we can use that to work out the moles of calcium nitrate. So CaNO3 twice is 69.5 grams, and water that's not right, is 69.5%, not grams. Okay, so therefore if we take a look at the mass of calcium nitrate, so we have 40 for calcium, plus we have 2 nitrogens which are 14 each, plus we have 6 oxygens. Okay, so the total mass of calcium nitrate is 164. Now that is equal to 69.5%. So if we divide that by 0.695, okay, that tells us that the mass of the entire hydrated crystalline must be 235.9, okay? 236. Now, we know that 164 of that entirety must be just the calcium nitrate. So 236 minus the 164 tells me that I have 72 grams of water in there. Okay, so that means that I have 72 over 18 equals 4 moles of water, and that is per 1 mole of the calcium nitrate. So in this instance, X must be 4. That's a trickier one, certainly. Okay, so you need to be on your mettle whenever you get a question like that at GCSE. Alright, so we will do another one. We've been given a very complicated, or a formula here of sodium carbonate, which is XH2O, and we were told that it was found to contain 62.9% water by mass. So you should be able to do this one now, having done the last one. We've got to again calculate the value of X. Okay, so you can pause the video, as you hopefully you've been doing all along, and do it, and then come back and see if you've got it right. So 62.9 is water. That means the rest of that must be made up of the sodium carbonate, which means of that we have 37.1%. Okay, and sodium carbonate itself is has got a mass of 106. So the MR of this is 106 is the MR. Okay. So therefore, the total mass of the entire thing must be 285.7. We know that the sodium carbonate, okay, is 106. So that gives me 179. Okay, so we will therefore divide that by 18, gives us 10. So therefore X equals 10. Okay guys, there's a question on the screen. It says a student found that cobalt chloride .XHCO contained 5.2 grams of cobalt chloride COCl2 and 4.32 grams of water. Calculate X. Alright, so I'm going to, if you pause this now, I'll reveal the answer. Okay, so the mass of cobalt chloride, RFM, is 130, so 5.2 over 130. Moles of cobalt chloride is 0.04. Mass of water over RFM of water is 0.24 moles. 0.24 divided by 0.04, x is equal to 6. Okay guys, that's me done. I'm not going to do any more of those. You should have hopefully gotten it by now. If you need any more assistance, there are lots of these on the internet, okay, in textbooks, etc. They're fairly common questions.